Hello everyone, welcome to my channel. Small introduction. Before we get started, I am a Singaporean student who just wants to help some people out who are struggling or missed a few classes and need to catch up. If you like this, please subscribe so you know when my next video comes out. It might be a help. By the way, if you do not live in Singapore, the syllabus might be different, but feel free to watch until the end. Okay, so this is Lower Secondary Science Chapter 1, the Science Endeavour. This is the first chapter of secondary school. It's something I would say a pretty easy chapter to get past. So, what will you be learning in this video? First, the scientific method, then fair experiment, followed by common laboratory apparatus, common hazard warning symbols, and the Bunsen burner. Here is an introduction before we start learning. Science is the study of nature to discover facts about them and how they affect living things and the physical environment. Now, moving on to our first thing on our list, the scientific method. Firstly, we'll be finding our problem. The first question you ask yourself is, what do you see? Is there something wrong with it? Yes, nothing is perfect. When you find out what it is, you list down the questions you have about it. Next, the hypothesis. A hypothesis is a prediction of the effect of changing one variable with another. A hypothesis is like a guess. It's not always correct, and it doesn't usually have to be. When a question like this come up, for example, give me a hypothesis from the experiment. As long as you give your scientific opinion, you will get the mark. This effect can be tested experimentally. Next, experimentation. First, you experiment. Do it at least 3 times and find the average. After that, you look back at your hypothesis. Were you right? Were you wrong? You have to say why, and it can't be a ridiculous answer. You have to actually provide a logical process to learn about the problem observation. Then, you have to record the evidence and then analyze the results. Last but not least, conclusion. You have to make an inference of the results to validate the hypothesis. In my opinion, I think it's basically a summary about the entire experiment. After the hypothesis is supported by several investigations, it becomes a theory. If the hypothesis is not supported by investigations, a new hypothesis will be established. A theory becomes a law of science when it's tested over and over again. Some of the desirable attributes of a scientist are curiosity, integrity, perseverance, creativity, genuine interest, patience, and willing to accept different opinions. If you didn't know, as long as you learn science, you're basically a scientist. These type of questions will usually show up in your examination, so look out for that. Next, we'll be moving on to the next part, designing a fair experiment. During the planning of an experiment, it's important to identify and to control the variables. Variables are factors that have an effect on an experiment. It's important to know the cause and effect between the variables you change and the variables you are measuring in the experiment. The 3 types of variables are independent, what you change, dependent, what you observe or measure, and controlled, what you keep the same. When collecting data from an experiment, it's important to know the degree of accuracy and precision. Accuracy refers to how close a reading or measurement is to the true or acceptable value. Precision refers to how close readings or measurements of the same thing are to each other. Now, we'll be moving on to the common lab apparatus. First is a test tube. If you notice on the left, there's a white box with a picture. That is the scientific diagram of the apparatus. The test tube is used to contain or heat small amounts of substances. Next is the boiling tube. It is used to contain or heat small amounts of substances too. If you look at the diagrams, they look pretty similar, don't they? The question is, how do you tell them apart? Well, it's actually pretty simple. The test tube is longer but smaller than the boiling tube. The boiling tube, however, is wider but shorter than the test tube. Next are the flasks. First up, we have the flat bottom flask. It is used to contain chemicals for preparing gases when no heating is required. The round bottom flask. It is used to contain chemicals for preparing gases when heating is required. How do you tell them apart? The flat bottom flask has a flat bottom. Easy? Let's move on. Now, we have the 2 stands that are used during the experiment, usually. On the top is the retort stand and the retort clamp. It is used to hold apparatus during the experiment. At the bottom, we have the tripod stand. It looks like a cup upside down. On top the tripod stand, there's a line. That line is the wire gauze. It usually comes in multiple axes. It supports apparatus during heating. Now, we have the measuring cylinder. The measuring cylinder is used to measure volume of liquid or solution or small irregular shaped objects. This is usually used in the volume experimentations. Next, filter funnel. This separates solid from liquids with filter paper, or to transfer a liquid from one container to another smoothly. If you're sitting there daydreaming right now, I recommend you don't. This would definitely come out in the exam. Now we are at the comma hazard warning symbols. This won't be so hard to go through. All it takes is just some active recall. Just remember the symbol, the name, and a small summary of the symbol, and you should be good to go. First, we have the explosive. The substance will explode easily when heated or mixed. It's pretty easy to tell it's an explosive by the look from the symbol. There are particles flying. Anyways, we move on to the radioactive. This substance can emit radiation. It might seem familiar to you from all the TV shows or movie you watch. Next, toxic or poisonous. This substance can burn the eyes or skin upon contact. This one is not a funny one. If you aren't careful, you drop it, you might be screaming in pain. How do you tell? There are bones and a skull as the symbol. Next, oxidizing substance. This substance releases oxygen to cause fire or explosion. Don't think it is a different symbol because of the fire in the back. Maybe think of it as a meteor. Now, health hazard. The substance can cause breathing difficulty or health issues. All the substances with symbols all have risk, so be careful. How do you tell them apart? Well, you see a person. That's, pretty straightforward. Now, irritants. The substances which can irritate eyes, throat, and nose. It's pretty harmful. How do you tell? It has exclamation mark. Sorry. Next is environmental toxicity. This substance can potentially harm the environment. It's pretty straightforward, it harms the environment. How can you tell? There's a dead fish and a dead tree as a symbol. Next, corrosive. Now, this substance can burn your eyes, so do not touch your eyes after you accidentally touch the substance. It will be incredibly painful. Now, flammable. Pretty straightforward. This substance can burn easily. How do you tell? There's a fire as the symbol. Next, compressed gas. It's a gas in a pressure container that may explode when heated or cause oxygen deficiency in an enclosed area when leaks. Remember, always be careful when you're in the science lab. Do not run around. You will get hurt. Yes, we are at the Bunsen burner, the last that we are going through. Don't fall asleep on me now. You chose to watch this, not me. This is the main diagram. I will stay at this screen for a moment in case you want to draw it down. If you still want to draw it down, you can always pause the video, okay? Now we're moving on. First, we're looking at the barrel. It's a location where gas and air are allowed to mix. Next, collar. It's how you adjust the intake of the air. Meter value. You regulate the amount of gas entering the burner. Air hole allows air to enter the burner. Gas inlet allows the gas to enter the burner from a gas. Base supports the burner. Now this, you have to pay attention to. If you do it wrong, you actually might get hurt. First step, you close the air fully before lighting up the burner. Then a luminous yellow flame will be obtained. To heat up the substance, open the air hole slowly. Don't do it quickly, slowly. If you do so, you obtain a non-luminous blue flame. The size of the air hole determines the type of flame produced. If you can't tell what is a luminous and a non-luminous flame despite the colors or find there are no difference, listen carefully. A luminous flame produced with the air hole closed is a yellow and orange flame. This flame is unsteady and flickering. It is definitely not suitable for heating. A non-luminous flame is produced when the air hole is open. It has a green and blue flame. The flame burns steadily and it's suitable for heating. Lastly, a strike back. This is also pretty dangerous, so be careful. A strike back occurs when you ignite a Bunsen burner with the air hole fully open. This allows excess air to enter the Bunsen burner. This may cause the flame to burn inside the Bunsen burner. So before lighting the Bunsen burner, remember to close the air hole. Straightforward, right? Yeah. And that is the end of chapter 1. I hope you got a deeper understanding of the chapter and enjoyed this video or lesson, whatever you call it. If you would like to see more, click subscribe. If you have questions about this chapter, feel free to comment them down. I'll try my best to answer them as quickly as possible. I hope I'll see you in the next video. Bye!